welcome back to our final morning session for today. Wikidata, linked data, all the data, knowledge representation for everybody. That is the title of our next lecture by Rebecca Kahn. So let me briefly introduce her. Rebecca Kahn is a researcher at the Alexander von Humboldt Institute for Internet and Society in Berlin, and the director of collections at Pelagios. She completed her PhD in digital humanities at King's College in London in 2017, and specializes in researching how digitalization changes the ways in which archives and museums approach and manage their collections. She's one of the coordinates of the Daria Geo-Humanities Working Group and is currently working on a project which combines Wikidata, ancient world gazetteers, and, of course, Asterix comics. Looking forward to your presentation. Thank you that you're here.
Thank you very much. It's great to be here. What I'm going to talk about today is possibly not all the data. I think that might be pushing it a little bit, but certainly a little bit about how Wikidata works, how Wikidata represents information, and how the logic of Wikidata, once we understand that logic, we can then start using the enormous power of Wikidata to start asking questions about whatever it is that we want to know about. So yes, I thought the goals for today are to give you an overview of the logic of Wikidata, teach you how to run queries in Wikidata, starting out with simple ones and then moving into more complex ones. And then finally, I thought what we could do is have a quick look at what I like to think of as Wikidata in the wild, which will be how Wikidata is being used by other projects, tertiary projects, and external to the Wikipedia and Wikimedia Institute, who are using Wikidata in interesting ways. But let's start with a brief overview of what Wikidata looks like. So if you go to wikidata.org, there's the front page there. You can see it describes itself as the free knowledge base with 93 million items. That number's going up all the time as people add to it. Like Wikipedia, anyone can edit it. So you can create an account for yourself and add information into Wikidata. And if you have a look on the left-hand side of that screen, you can also see that there are a couple of links to other services. The one being the query service, which we're going to spend quite a lot of time looking into. There's interesting lexicographical work being done on Wikidata. Unfortunately, I don't think we'll have time to look at that today, but it's also a really interesting area where there's a lot of development happening. And then you can also see, if you were to scroll down at the bottom where it says in other projects, you can see how Wikidata is connected to projects like Wikimedia Commons, Wikisource, Wikipedia, and the other kind of entities in the Wikimedia space. But for starters today, I thought we could talk a little bit about what Wikidata is. So what is Wikidata? Well, Wikidata is a knowledge base, which is the central storage for the semi-structured data used by Wikipedia, Wikimedia Commons, Wikisource, and other projects, as well as many other independent and tertiary projects, which I'll show you at the end of this session. It combines multiple kinds of data, so bibliographic data, taxonomic data, GLAM data, such as images or video. It's massively multilingual, so Wikidata doesn't have the same language issues that Wikipedia has, for instance, because of the way that knowledge is structured in it. It's language agnostic, and it is freely reusable. So for instance, on the right-hand side here, what we see is an example of the kinds of data that Wikidata combines for the subject, Lord Byron. So you have a kind of narrative text from Wikipedia, you have his image from Commons, you have Wikisource with links to all of the accessible sources on and about Lord Byron. And then at the bottom right, you have some of the information related to Lord Byron arranged in the format that Wikidata uses. Now, what's important to know is also what Wikidata is and is not. Unlike Wikipedia, Wikidata is not a source of narrative. It's not going to tell you a story, or at least not immediately. What it will provide you with is human and machine readable data, which you can then connect in order to tell your story. It's also not a relational database. It's an object-oriented database, which I think if you were working with Sparkle earlier today and yesterday and over the course of the next day of this spring school, you'll be thinking a lot about how data is arranged. And at first, it might not make sense that Wikidata is not a relational database, that it's an object-oriented database. But what I'm going to show you in the later slides is how actually, although Wikidata is not a linked data repository per se, it is actually possible using the arrangement of Wikidata in semi-structured form to almost replicate the functionality of linked open data, but without using a linked data repository. So in order to kind of understand what this means and how it works, let's have a look at the Wikidata data model. So what we see here is the subject, Douglas Adams, the British author. And what we see in this is various component parts of the entity Douglas Adams. And the most important parts for us to think about, first of all, are what we see at the top of the screen. So there's a label, an item identifier, and a description. Now, an item identifier is what every single item in Wikidata is assigned. That is a persistent identifier which will never change, which allows the basic information required to identify the topic that the item covers to be translated between different languages and also between different systems. So whether you're thinking about French Wikipedia or Arabic Wikipedia or English Wikipedia, the item for Douglas Adams is always going to be Q42, which if you've read his books, you'll also know is a little bit of an in-joke about the answer to the meaning of the universe. And the other important thing to know about this identifier, this Q number, is that it can be appended to any URL in order to direct you to the conceptual space for that entity within Wikidata. So for example, here you can see that URL at the top of the screen, that will always send you to Douglas Adams. So what we see below the label, the item identifier, and the description is a whole lot of other information about Douglas Adams. And this representation here isn't quite 100% accurate. It's sort of been chopped up a little bit in order to show you the most important parts. But we can see here, for example, where he was educated. And each of those bits of information has a value and some qualifiers. And these values and qualifiers are grouped together in something called a statement group. Now, it may seem a little bit confusing at the moment, but I'm going to break it down a little bit more for you so you can understand what all of these different component parts do. So essentially, anything in Wikipedia is an arrangement of information in the form of items, statements, properties, and values. Items are things, and they can be conceptual things like the summer of love, or they can be more realizable things or concrete things such as gorillas or the periodic table, or they can be more than one thing at once, so to speak. So for example, the item Jane Eyre, you'll see here there are 3 different versions of Jane Eyre that are available. And that's because the term Jane Eyre doesn't mean very much to a computer unless you specify which Jane Eyre you're talking about. And so it could be the one version is the novel, the one version is the television adaptation, or the version that is the fictional character who is in the novel. Now, the labels that are used, the exact text Jane Eyre, don't need to be unique. They can look the same immediately, but it is the combination of the label, the Q number, and the short description that creates the object's or the item's unique identity. So an identifier is always going to be linked to a pair, a label and a description. And that kind of 3-part structure is what dissolves any ambiguity about what item we might be talking about. So if those are the items, what comes next is the statement. Now, a statement is basically how any information about a topic is recorded in Wikidata. And a statement consists of key value pairs, which will always map an item, a property, and one or more values. So what does that actually look like? Well, what we can see here for Marie Curie, who is the item Q7186, with a short description, a Polish-French physicist and chemist. What we see here is a series of properties with a P number, identified by a P number, which are then extrapolated upon, I think would be the word, with a series of other Q numbers. So, for example, we're able to start building up quite a complex grid of information here about Marie Curie, right? Because she has an occupation. That occupation is a property with a P number. And as the additional information here is that there are multiple Q numbers. So her occupation was a physicist, a chemist, an academic, and a nuclear physicist. And her country of citizenship was France, Poland, and what was then the Russian Empire. So each of these items has a unique Q number or P number attached to it. And in stringing these Q and P numbers together, we can see how Wikidata starts to build these like really in-depth networks of information. Now, technically, these are not the same as an RDF triple, but you can see how conceptually they're very, very similar things. And I actually tend to think of them as RDF triples because it helps me to understand the way that Wikidata works and the logic behind it. And I think unless you're doing very technical development work with this kind of stuff, it doesn't hurt to think about them in the same way. Now, properties and values. So at a general level, if we think of properties as the categories for the data and values as the variables that can be classed within these categories, it helps us to think a little bit about what they are. But thinking about them at the general level means that it's a little easier to think about how they fit together. So for instance, the item Saturn with the Q number 193, its property is that it's an instance of, and then two values, a gas giant and an outer planet. And if you think about an item, a property, and a value as the kind of logical route to reveal or to represent knowledge in Wikidata, it'll help you think about how to either request information through a query or how to add information if you're wanting to add contextualizing or verifying information into a Wikidata project. Now, to my mind, a lot of this stuff doesn't really make sense until you see it in action. It's kind of an abstraction. It's a way of like trying to represent how things work. But in my experience, the only way to feel comfortable with Wikidata is to really get stuck in and try running some queries for yourself. So what I'm going to do in order to do that is take us into Wikidata itself. I'm taking it that we're all still happy. We can all still see my screen. And we are going to run our first query in Wikidata. Now, it might seem a little bit alarming at first when you're faced with the Wikidata query service like this to know where to begin. But fortunately for us, the people who created Wikidata are lovely people, and they have given us some tools to help us. So the first thing I'm going to do is pull up a query from the examples tool. Now, there are about 400 example queries that have been created here that we can just click on and use ourselves. And I'm going to use the cats query. And before we run the query, I'm going to talk you through all the kind of component parts of what this query is, kind of an anatomy of this query. So basically what we're doing here is we are going to ask Wikidata to look for something for us. And anything that we put behind a hash in Wikidata, or almost anything that we put behind a hash in Wikidata, will be ignored by the computer. So it's a handy way of keeping notes for ourselves. So here we've said, okay, this is a query about cats. And the next line is the select line. Now the select line is essentially going to tell the engine what we wanted to find for us. And what we wanted to find for us are all of the items and their labels. Remember the short description under the item. And now we're going to give Wikidata in line 3 a set of conditions that define what it is that we want those items and those item labels to be. So in Wikidata, when you want to run a query, you need to delineate the specifics, those variable specifics within 2 blocks. Those 2 blocks are defined by curly brackets. So you put the opening and the closing of the curly brackets there in line 4 and line 5. And now we want to tell Wikidata that we're looking for a particular item. So the item here is behind a question mark. That means it's a variable. It could be any number of different things. And we're going to ask Wikidata to show us 2 different things. And the 2 things that we're going to ask it to show us of is all of the instances in Wikipedia of a house cat. And you can tell a useful way of doing it is to just hover your cursor over the screen and you'll be able to see those 2 values. Now, the final line of this query is kind of long and scary. And I would suggest that we don't get too caught up in it at the moment, that we just leave it there for now, and I'll show you what it means and its significance as we get further in. So we know from the way that we talked earlier about a Wikidata query that everything can be broken down into items, properties, and values. So essentially what we've got here is the item, that variable there, it's going to show us an item, a property, which is always going to be represented in a Wikidata query by a WDT, property, a T, that's how I remember it. So the property here is going to be an instance of, and the value we're asking Wikidata to look for is house cat. So let's run this and see what we find. Okay, so in a very short amount of time, Wikidata has given us 150 results for house cats. And what we see here is the distinction between an item and an item label. In Wikidata, an item is going to be a Q number, and the item label is what gives us the kind of human speak variable of that. And so we can see here that we have 150 examples of cats. And these obviously are not every single cat in the universe. These are cats that are notable enough by some definition of the community to have made it into Wikidata. So if we have a look here, this cat, Wilberforce, it's an interesting name. Let's see what it means. Wilberforce is a cat. He is the chief mouser, or was the chief mouser to the Cabinet Office in England between 1973 and 1986. And in fact, his position, he was replaced by Humphrey and he replaced Peter. So those were also 2 house cats that came before and after him. And here we can also see that he was named after somebody. So there's sort of layers of significance here. Now let's just go back into our query and see. The one thing I didn't mention earlier is that whenever you put a query into Wikidata, it must be followed by a full stop. That's really, really important. I'll probably make a mistake later on and leave out a full stop, and you'll see it invalidates the query. Now, another thing in Wikidata that might seem a little confusing at first is that, like, how are you supposed to know what all of the P numbers and Q numbers are for 90 million odd entities? So again, because, you know, Wikidata people are lovely, Wikidata developers are lovely, they have created a little tool that helps you auto-complete that. So for example, on a Mac, and I'm not 100% sure what it is on a non-Mac machine, unfortunately. If anyone knows, please put it in the chat. You can use the Option and the Enter key And that gives you a autocomplete, and you can start putting in the information. So we were looking at cats. So I start typing cat, and there it says, house cat, the domesticated feline. I can click on it, run it, get the result. If I wanted to do it for dogs instead, all I would need to do is type in dog. And there are many different options here for dogs, but I want the domestic animal of dog. And I get another response. The other thing is just to show you, so I've labeled this query cats. If I were to label this query moose and run it, I'm still getting dogs. So you can see that that doesn't make any difference. The other thing you can do, which I find really helpful, is to make notes to myself through the query. And as the queries get more complex, it helps you to pass your way through it. So just here I've said instance of dogs. And again, run it. It doesn't make any difference to the query. So that's an example of a really simple query in Wikidata. But what if we want to start building up slightly more complex queries? Like, we know that there's a lot of power in Wikidata. We know that we can get really detailed information out of it. How do we start looking for that information? Well, basically, all you need to do is tweak and adjust your properties and your values. And so essentially, without having to learn too much, you can start building out much more complex queries. So what I thought we could look at is, earlier Rainer showed us examples of books that had botanical information from Styria. And I thought it might be quite cool to look at a little bit more of this botanical information, also this information around botanical illustrations, also because when it comes to looking at images, we might be able to find some quite nice images there. So for the next query that I want to show you, I thought what we could do is start looking for examples of people who are botanical illustrators. So we can change the title of the query to botanical illustrators. And instead of dog, we want to see botanical illustrators. Sometimes you spell things wrong. Now, there are lots of options here. So there's botany, botanical gardens, botanical journals, botanical collectors, we might be getting there, botanical illustrators, Q3148760. So an instance of botanical illustrator. Now, if I run this query as it is, something's gone wrong. I'm not getting anything. So what do you think has happened here? When you get nothing in Wikidata, you know that you've made a mistake. Now, the problem could be in the select. It's possible that I haven't told Wikidata exactly what it is that I'm looking for. So I look there, I'm looking for an item and an item label. Is that the problem? No, that's not the problem. So if I scroll down again, what could the problem be? Okay. So here's one of the mistakes that comes up often in Wikidata when you're beginning to get used to it. An instance of a botanical illustrator is not going to give you the answer that you want, because in Wikidata, instance of is not, instance of gives you the kind of most basic essence of the value that you're looking for. And people, because we're going to be looking for people are not born botanical illustrators. People are born as humans. So what you have to do with Wikidata, and this is an important part of the logic that you have to understand when you work with it, is you have to start at the highest level and then get more and more and more specific. So what we need to start out with is an instance of a human. So we start out with human, Q5, and you will probably end up using this a lot. Instance of human. And now we want to explain to Wikidata that we want to look for humans who have a job, and their job is botanical illustrator. So the property is, has profession or profession. So that I know is P106. And I only know that because I've done this many times. Occupation, P106. The value I want to add onto that is botanical illustrator. Oops. Come on. Botanical illustrator. Put in my full stop. And then we say here, occupation. And now let's try and run it and see what we get. Excellent. So what we have now is 810 results of botanical illustrators. And again, we have the item and we have the item label. So at least we have a name. But what we don't have is a description. Now, it might be helpful to know a little bit more about these people. And we know that for every Wikidata item represented by those Q numbers, there's a little bit more information available. So what I'm going to do is I'm going to add the variable here, item description. And by adding item description, and the capital D is really important, what I'm going to do when I run the query again is create a third column called item description. And there I have a little bit more of a description about who these people are. Now, essentially what we've done here is we've created a pattern of statements, a pattern of statements that we are now asking Wikidata to copy and to find every result that matches that pattern. And if you think about it that way, it also helps to understand the way that Wikidata works a little bit more. And essentially what we can start doing now is expanding these patterns in infinitely complex ways. So for example, here we have these 810 illustrators, and we don't know very much about them. For some of them, it gives us where they come from. For some of them, it gives us dates. For others, it doesn't. For some, all we have is scientific illustrator. So let's say I want to now maybe eliminate some of these results because I want to start getting a little bit more specific. What about trying to find botanical illustrators who are not British? Now, this is a very straightforward thing to do. All I have to do is tell Wikidata that I want to start looking, for results that match the pattern of not British. So one way I could do it is to think, okay, well, if someone is British or not British, maybe I could start out by eliminating those who are born in the United Kingdom. So what I want to do now is I'm going to add another variable here, and I want to say birthplace, because I want to know where those who I'm going to have included in my results were born. And let's see what happens when we do that. So if I now add, we've got P31, that's going to give us the instances of human. We've got P12, which is going to give us botanical illustrators. But now I want to leave out those who are born in England. All I have to do is put in minus. That's the instruction that I'm giving to Wikidata. And I need to remember that any information that I'm going to ask Wikidata to ignore needs to also be contained within a block that is defined by curly brackets. So I want to leave out any item that has the property of birthplace. So option and enter place of birth, 19. And I want that place of birth to be England. Let's start out with England and see what happens. So again, autocomplete, and I can say England. Oops. England, Q21. Now, close the full stop, close it with a full stop, in the curly brackets. And let's see what happens when I run the query. So what I can see now is my birthplace column is empty. And I've got some fewer results, not a lot fewer, but some fewer. So perhaps what I can do now is find out, just to be doubly sure, I'm seeing Germans, I'm seeing Austrians, some Americans, some Dutch results. So I think what I've got here is accurate, but let's make doubly sure. Let's see if we can see what their birthplace is. So in order to see what their birthplace is, I need to add another line to the item. Now, I can put that before or after the minus, it doesn't really matter. But what I want to show is I want to show item, and I want the value of birthplace. Now, I'm not asking Wikidata to show me, to find me something new, because it's already found all of these entities, all of these Q numbers. I just wanted to give me a little bit of extra information. So instead of providing it with a WDT, with a property and a value, all I'm going to ask it for now is a property. So WDT, and the property that we know for birthplace is P19. And now what I'm going to do is I'm going to tell Wikidata to put that into the birthplace column. So the variable there is birthplace. And now let's run it and see what happens. And I must remember to put the full stop in. Again, I've got something, it's giving me a birthplace, but it's a confusing and somewhat inscrutable Q value. Now, I could go through this and check and see which one they all are, but that doesn't really help me very much. So what I need to tell Wikidata in the select column is to show me the label for that birthplace. So I've defined the variable of birthplace, and now I need the label, and let's run it another time. And now I have the places where these individuals were born, and I can see, looks about right, but hang on. Here I can see, if I scroll down, Margaret Mee, a British botanical artist born in Chesham. And here I can see Eleanor Fortescue Brickdale, another British artist who was born in London. Now I thought what I'd done here is I had said, I don't want anyone who's born in England. Now, there are a couple of ways to kind of dig through this information and figure out what may have gone wrong here. One way you can do it actually is to have a look at a different representation of this information. And the way that you can do that is to ask Wikidata to include the coordinates of the birthplaces and then visualize it on a map. So if I want to see the coordinates, what I need to do is add an item into the select. So variable, and add coordinate, and add one more line here. And what I'm asking Wikidata to do here is to, for the birthplace variable, I'm going to ask for the property of P625, which in this case happens to mean coordinate location. So close it, run it, and let's see what we find. Oh, there's a problem. I've forgotten something here. I need to add that this is the coordinate. So variable, coordinate, full stop, run it again. Right, so now what we have here is the coordinates of where all these people were born. And because Wikidata is a powerful, powerful tool, I can now visualize these results in different ways by clicking on the visualization tool on the bottom left hand there. And one of the things I can do is see it. If it has coordinates, I can see it as a map. Now here is this map, and I can see several things with this map. The one thing that this map tells me is that in Wikidata, like many Wikipedia projects, there is still huge knowledge gaps because we have very few results here from India, from the subcontinent. There are very few results from Africa and very few results from Latin America. Whereas the United States, particularly the East Coast and Europe, we have a lot of information. Now, this is partly because of what has been deemed to be notable enough to be included in Wikidata. And there are many different initiatives running within the Wikidata community to get more information that is more representative of the way of knowledge of the non-Western world into Wikidata. And this would be a good example of looking perhaps for botanical illustrators who are not Northern and Western people. But if I zoom in a little bit more and I want to try and solve this mystery about illustrators who are not English, what I can do is I can zoom in, and each dot here represents one entity or one item. I click on that, and what Wikidata gives me is those two variables that I had asked for. So it gives me that they are a botanical, that this person, Sarah Ann Drake, is a botanical illustrator, that those are the coordinates of where they were born. And what we also see here is Skaton is listed probably as the place of birth. Now, Skaton, we know, is in the United Kingdom, it's in England. But they probably, if we look at Sarah Ann Drake in Wikidata, and we try and find out what information is here in terms of where she was born, we see her citizenship is of the United Kingdom. Her place of birth is Skaton, but there is no extra information there about whether she is English or perhaps she was Irish but born in England. She may have been Scottish. So this makes an important point, I think, about the fact that in Wikidata, not all data is standardized. And you need to remember that when you are asking Wikidata to look for different things for you. Because what it means is that you need to remember to pass out your query with as much detail as possible in order to get the results that you're looking for, because you can't make any assumptions about how Wikidata, how the information is arranged in Wikidata. So that was the second query that we did with exclusions and map views. The other query that I wanted to show you is the query that gives us the option to look at images. Now we know that in Wikidata, there's often a lot of information available which contains images, either images of the people or associated images. We know that Wikicommons is a really big resource and there's a lot of that information available. So in order to do this, what we can do, if we're looking for our botanical illustrators, and let's go back to the original. So we want to see all of them, so we'll take out the minus. And we can keep the information about the birthplace and the coordinates. It can't hurt to have it in there. But let's say we want to see an associated image. All we have to do is add another variable here. So instead of it being an item, we want it to be an image, because we know that the items have already been found. And that item's value is going to be the property of image. So if I use the autocomplete and start typing in image, P18, an image of the relevant subject, and add here image, and add here, put the top image. Let's see what we find. There's going to be a problem. Can anybody, if you can spot what the problem is going to be? Sometimes these queries can take a little while. The problem is, again, that I forgot to put the full stop in. Let's run it again. Again, something's missing. So when these things happen, and they happen all the time, or at least they happen all the time to me, it's really important to go back and pass through it again. Perhaps the problem is here. I change that back to item and then define the variable as image, let's see what happens now. Now we have a link to those items in Wikidata Commons. And what's also interesting is you see here, suddenly there are only 171 results. Now we've gone from 800 something results to 171 results. Something's going on here. Essentially what we've done here is we've told Wikidata we only want to see those items which meet exactly these criteria. So they have a place of birth, that has coordinates, that has an image. So I'll talk in a minute about how to make adjustments for that. But another option here with Wikidata is to look at an image grid. So we can see here what we find is the associated images for all of those entities that we were looking for. Now, one option in order to expand our search a little bit and make sure that we don't lose so many people by being overly specific is to either take out certain items. So if we decide that the idea of the birthplace or their coordinates is not that important, that would be one way to broaden our search. Another way to do it is to tell Wikidata that we want that information to be optional. So the way to do that will be to tell Wikidata that having an image is optional. Optional. And remember, if we give it a new instruction, we need to put it into curly brackets. And if we run that, what we see now is we have a much larger result, 441 results, and not everyone here meets the criteria of having an image. So this is one way of making sure that you can make allowance for the variations of what information is in Wikidata or not. Now, what if we wanted to look for people who weren't just botanical illustrators, but who were botanical illustrators and perhaps explorers? Because these periods, these early periods of exploration, often people did both of those things. That would be very simple. As again, we just add the item and the occupation, P106, and we want an explorer. Explorer, full stop. And now we would imagine that we will get many more than 441 results. But let's see what happens. 19 results. How come we're only getting 19 results here? This feels a little bit strange. Well, it could be, again, that what we're asking Wikidata to do is to be far too specific. Because what we're saying here is we want human beings who not only are botanical illustrators, but are also explorers. But what if we want Wikidata to show us people who are either botanical illustrators or explorers? The way to do that is to use the function union. Now, the union function tells Wikidata that what we want to do is join two sets together. Essentially, what we've asked Wikidata here to do, if you're familiar with set theory, is show us the intersection between two sets. But now what we want Wikidata to do is give us the superset. So the way to do that is to type in the function union and put the two conditions that we want to be joined together into curly brackets. So we want Wikidata to show us everyone who is a botanical illustrator everyone who is a botanical illustrator or an explorer in one result. And if we run that query, you see we suddenly have a lot more results. We have 5,000 results. Now what we could do is we can start playing with these variables and eliminating certain objects or eliminating certain entities, including certain entities. But essentially what we've done is we've created quite a complex pattern here that we're asking Wikidata to meet.
And maybe if there are questions for now, so we can have maybe a short question answer round, if there are some.
Yeah, absolutely.
I have prepared one question.
Oh, excellent. Phew, I hope I can answer it. Maybe I
can't. If you have, maybe if we assume I have a small project and I would like to enrich my data by using Wikidata, what strategy would you suggest to get to all these QIDs?
That's a really good question. So it's, unhelpfully, I'm going to tell you that it depends. And it totally depends on your project. So a project that I worked on recently was to try and create a list of every place in an Asterix comic that had a Wikidata QID. And what I discovered very quickly is half of these places were fantasy places and didn't really exist and were not historically accurate places. So what was I going to do? And the only way for me to do that was to actually create them myself. So I actually used Recogito to annotate a bunch of places, which I used a combination of scans and tabular data, and then had to manually go through it and create Q entities for all of these places. Now, fortunately, what I was able to do for a lot of them was you can't just throw anything into Wikidata, right? Everything has to be verifiable. And the way that that is done in Wikidata is by having what is called, you have the statements, which we explored earlier, and then you also have the information that validates that statement. And that information is called, in Wikidata, it's called an identifier. And it's basically any external source that can be used to say, this, I know this to be true. So what I was able to do is go through all of these Q numbers that I created for the different entities and then find versions of them. And actually, funnily enough, a lot of them did have versions either in other texts or in different gazetteers, and was able to make those connections between the two, which verified them and therefore validated their existence in Wikidata. I see there's a question in the chat about an ontology of Q elements. There've been some attempts to make them, but it's huge and it's always growing. So it's quite a difficult ontology to keep control of. But yes, there is. And the best way to find it is actually in the Wikidata community portal. If you go in there and you look for it, you will be able to find that ontology. And you will also be able to see the logic behind the ontology in terms of the kind of philosophical approaches that the Wikidata community has taken to like how things were assigned numbers, because it wasn't just random, right? They didn't just like start at number one and work their way down. It's more complex than that. I should also add that because this is a community-run project, it's also always changing. So there have been certain properties that have been discarded and are no longer in use, specifically ones around gender and gender identity as language has changed and ways of representing this kind of information have changed. There have been certain properties and also, I don't think any Q values, but certainly certain properties that no longer exist. Another one is grandparents. So rather than defining grandparent, you will have a father's father or a mother's mother or a mother's father or a father's father. There is no longer a kind of catch-all property for grandparent. And there are very interesting discussions around this stuff, which you can read in the kind of back layers of Wikidata.
Okay, thank you very much. Are there any other questions? If not, then thank you again for this much deeper insight into Wikidata. I think that very well completed today's session about Sparkle and Recogito and on all of it.